want to quickly introduce myself. Thomas Pan, organizer of this meetup. And on top of that, we have other people helping out. We have Chris at the back. What's that person? Ajit. Yeah. And Brian Jiang as the video man. And we also have Brian Johnson, who started this meetup series. As normal, anybody want to make any announcement? Anyone? Nobody? All right, Brian.
BAS hiring for search. If you're interested, you can talk to Chris. He's in charge.
All right. So tonight we have a great speaker from Evernote. I think most people are familiar with this company, and her name is Zeesha. And so without review, I just hand over the microphone to her. All right.
Okay. Okay, hi everyone. I am super excited to be here and to be talking to all of you about search and augmented intelligence at Evernote. So I'm Zeesha, and I head the AI team at Evernote. Of course, we're hiring as well, so anyone interested, please come talk to me later. So I wanted to actually start off by telling everyone what Evernote is about, because I think that there are some people who don't know what Evernote is. And for all of you, Evernote is not just a note-taking application. Evernote really is your workspace. We want to be the place that you work in. It's this really great concept of Evernote being the place that you can write, distraction-free, in a really clean, native, beautifully designed interface, no matter where you are across all of your devices, allowing you to kind of jot down anything that's on your mind. It's also the place that you can collect anything from the web, whether it's a news article, whether it's research. You can put in any of your documents, presentations, Excel files, Word documents, whatever it is. With the expectation that, once you do these things, you can always find anything that you put into Evernote, very seamless. And the key here is you can always find it, not search for it, because you can do more than just search. And once you have this, it also allows you to present your ideas, communicate with people in a great way. So Evernote really is, it is your workspace, it is the place you work, and the more you work in it, what you tend to accumulate is this really rich body of information that identifies who you are. It's your entire life's work. Whatever you want to achieve, you can use this to get there. And we have an AI team at Evernote. Now the goal of the AI team, or the augmented intelligence team, is to help make a user smarter. Okay, so the more you use Evernote, the better we want to understand how you work, how you live, how you think, and be able to, just with the right amount of machine intelligence. So that's really key. The right amount of intelligence, be able to amplify your abilities. So at the end of the day, you should feel that you're more productive, you're more in control of your life, you have the ability to make smarter decisions. And we can see, with some of the examples that I'll give you in the presentation as we go on, how we're trying to do these things. We're a core software development team in the company. Our team comprises of engineers, designers, quality assurance folks that help realize this vision. We're super passionate about making this difference. That kind of begs the question, a lot of people ask, what do we actually do and how do we do it? We use really advanced software engineering techniques, machine learning techniques. Really the core of it is more information retrieval and search technologies to be able to do all these kinds of discovery applications that surface the right information at the right time for our users. So that's what, in a nutshell, the AI team is attempting to do for it. Now, let's talk about search at Evernote. So, of course, when you go into Evernote, there's a search box. You can type in keywords, it'll do a keyword search. That's a no-brainer. But it does more than that. When you search for a keyword, not only does it recover, or not only does it find all of the nodes that have a match, a textual match in the node content, but it goes beyond that. It also is able to pull up all the images or the text within these images as result matches, so not by relevance and things like that. So, this is, I love food, I love cooking, I love eating. It doesn't show, but I absolutely love it. And this is, one of the pages of Food Network magazine that I clipped the other day when the only thing I had in hand was my phone. And it's a really good recipe, by the way, of oven crispy fries. And I know that whenever I want to make something like this, all I have to do is search for keywords, and it would find the matches within an image that I took of this magazine. And so now I have my entire Evernote account filled with pictures of my, the yellow crinkly pages of my grandma's recipe. It's amazing. But it goes beyond that. It searches within Excel files, within PDFs, within presentations, within keynotes, whatever it is. So you know that no matter what you put into Evernote, you can always get it. Evernote is not just a dumping ground of information, not just a dumping ground for all of the stuff. Whatever you put into that is kind of used for your benefit. And so this is the right thing. We definitely do stuff like Type Ahead. It's all over the place, but our implementation of Type Ahead is way more complicated just because of the collection, the kind of nuances of our collections, and we'll see about our purposes later on. But we definitely do Type Ahead search, showing you keyword matches, phrase matches. We do spelling correction. What's really cool about the way we do spelling corrections is that they adapt to the way you spell things. So I tend to spell the word colorful like the British way with C-O-L-O-U-R. If I search for C-O-L-O-R, it'll kind of recognize the way I spell things, and it helps correct my spellings the way I tend to use them. We go beyond just search. So like I said, Evernote is going to help you find stuff. And find is not equal to search, it's more than search. We do things like anticipating what nodes you want when you want it. So before you even go into the search box, and before you type in a single character, we would try to show you the nodes that you are likely to want. This is a screenshot of the iOS application, and it does this based on trying to figure out predictive matches based on your calendar accesses, based on your usage history. If you access the same node, the same place, the same time, it'll know that the next time you're at the place, this is probably the node that you want. So it does smart kind of predictive analysis on these kinds of things. We also hook into Google. So if you are searching Google, we have a Chrome extension. So if you go into Google and you search for something like app development, alongside the search results that come from Google, you would also see results from your own Evernote account that are relevant, not only to your query, but also the results. So right in line, I search for Mac development. What I get over here is, a jog of memory to tell me that I've already done this research a year ago. I already have all the links regarding Mac development collected and curated in my Evernote account, and it just shows me that seamlessly. I don't need to go into anything additional. But what's really fun here is to notice at the bottom, you'll see someone called Mike. He's actually a person in Evernote who is the core Mac engineer. So we go beyond this, saying that we would also show you who to talk to next. Sometimes the easiest way to get to information is by striking up a conversation with the right people. So we help to surface the right people who you should have that conversation with. All of this is within our Evernote business offering. So of course, no data is kind of compromised, no data privacy boundaries are crossed. Everything is information that you have given access to. I could easily just go over to Mike and be like, what do you know about Mac development? So that's kind of cool. We call that feature expertise search. And then we've recently launched this feature called Context. I don't know how many of you know about it, but we do more than just surfacing notes from your own account. So as you are typing, as you are viewing information in Evernote, we show you not only notes from your own account that are relevant to what you are working on, but we also show you information from the web. for example, news articles that are very relevant to the task you're trying to accomplish. If you're going into a meeting with Netflix, we would show you that, hey, right now Netflix is trying to increase prices. And that would highly inform your meeting or help you be more aware and have more productive meetings and discussions about these kinds of things because you're just now more aware of them. It would also show you profiles from LinkedIn, if you're planning to meet with certain people, it would pull that information up within Evernote business, companies and people as well. So it kind of brings you all the relevant information at the right time without you having to even think about search. This is beyond that step. You haven't thought to go and search, but we try to show you information that would help inform you. So these are kind of some of the applications that we have built so far, our current search solutions. And at the heart of all of this is Lucene. Lucene really powers our entire search infrastructure. Not Solar, plain old Lucene. Now, I'm going to share, that's kind of the high-level spiel, but now let's go into some kind of details. I want to share some insights into our infrastructure. So Evernote currently has 100 million plus users worldwide. We have sharded architecture, so we have 100 million users supported across close to 700 shards. All our users are isolated, so a single user belongs to a single shard. All the information is encapsulated on that shard. It doesn't cross shard boundaries, it doesn't cross group boundaries. The shard runs Linux, MySQL, Tomcat. Pretty trivial and pretty kind of naive approach, but it works really well. And then we have Lucene. We have image recognition processors that process close to 5.6 million images for recognition data. So every time you take a photo on an Evernote client, it would send it to our image recognition servers in the back end. They would extract all the text from the images and send it back to the servers to add to the index. So that now, all of a sudden, you have the capability to search within your images. That's how that technology is powered. We have close to 31.5 terabytes of MySQL data. This is across all our users, across the collections of data that they then store. 800 million each requests daily, and 4.4 billion links have been created. So as you can see, we have a pretty large scale system, but we have one Lucene index per user. So even though we have kind of all this huge scale of 100 million plus users, at the end of it, we have single Lucene index per user. So our search problem is not one huge big data problem, which is kind of typical for most companies these days. It's 100 million plus much smaller data problems, but seriously, 100 million plus small data problems. So, this type of collection poses very different type of engineering challenges. It's kind of the challenges that not very many people are used to thinking about, but when you think about search, our challenges that we're trying to solve for are quite different. So let's talk about the search system that we have. So of course, we have 100 million plus Lucene indexes that power our search capabilities. We have Lucene 4.x that powers our search infrastructure on our server. When I joined Evernote, we were still using Lucene 2.9, and it worked great. Functionally, it worked great. We did have a lot of issues with disk I/O, with memory, and we reached a point where we decided that it was time that we upgraded to Lucene 4. Lucene 4 was highly backwards incompatible with 2.9. And so that was kind of one of our big challenges. How do we migrate 100 million Lucene indexes now from 2.9 to 4.0? And one of the engineers on our team, Christian, did a really good job of architecting the system such that we could run two different versions of Lucene, 2.9 and 4.0, on the same VM. So we could have one user whose index is 2.9 and one user whose index is 4.0 in the same system. It's pretty great because it allowed us to very seamlessly migrate all these millions of indexes with less than a minute of downtime per user. So literally, we did a complete full migration, preserving all the data, no data corruption from Lucene 2.9 to 4.0 with nobody ever noticing. Like nobody. Besides, of course, operations at Evernote. Nobody else noticed. And operations at Evernote didn't a lot. They're all we have the, as I said, we have air processors, which is our image recognition processors, asynchronously update the index. So every time an index node is called, it sends off a request to our image recognition servers, comes back, asynchronously updates the index. We have service APIs. So our end service search functionality is provided by service APIs via Drift protocol. But what's interesting is, as you know, Evernote lives across all of your devices. So across your Mac, across your Windows, your iOS, Android, we even have BlackBerry support. We're any platform with it. And what's interesting is all of our clients, like all of our desktop clients, actually maintain their own index. And that's because we care very deeply about user experience. I mean, it would be a pretty crappy experience if every time someone tried to search, they had to hit the internet to kind of get results back. And so we definitely want to support an offline search capability. And the way we did that was have each of these sets of clients build on their own index. So they all do their own indexing, they all store local copies, everything is native, which makes it hard when we try to deliver kind of these search solutions across platforms, because now we have to engineer it either kind of for each of the platforms that we're supporting. Our Mac client uses Lucene, it's supported Lucene, but it's actually on version 0.9. It's pretty ridiculous. I mean, I don't even remember when that was actually introduced, but it works. We haven't had any problems on it for now, till now at least, and there's no compelling reason anytime in the near future for us to upgrade that. There's just one version later, I think that C port has, so we're not planning to. Our Windows client uses SQLite, which comes with a whole different slew of problems. But all our thin clients, all our mobile clients basically use service APIs to search. All of our more advanced search functionality, like related nodes, expertise search, is all exposed on our service APIs as endpoints. So even third-party developers can consume this when they're developing applications that work end-to-end together. So that's kind of how we've architected our backend in some of our clients. Now, as I said, we have very unique search challenges with Evernote. Our search challenges basically stem from the kinds of data that we're dealing with, our forms. Like I said, if we're maintaining a single index for each user, that really means that our search solutions have to scale with a user that has 1 node in their account, and a user who has 10 nodes in their account, and 50 nodes, and 1,000, and tens of thousands of nodes. How do you develop very smart, intelligent algorithms that work on like 50 nodes, 10 nodes, when just statistics are all over the place, and you can't really do anything reliable with them? And that's kind of the second problem, which is how much weight do we give to statistics like IDF? Like IDF is basically, for those of you who don't know, it's inverse document frequency. It kind of helps measure how rare something is and kind of give it a weight in the ranking formula. But if someone just has, let's say, 10 nodes in their account, you can't really rely on any of these statistics to make sense. They're not significant. And so a lot of times we spend time kind of looking at these ranking functions and seeing how do we optimize for these distributions, how do we optimize, and how do we augment our statistics. Of course, it becomes harder when every client is maintaining its own index, because if you're trying to do this on a Mac client, you don't really have the luxury of dumping like huge collections of parallel statistics. It's just not going to work. So we do a lot of kind of modifying formulas to make them actually work for us. We have highly unstructured data. We have users who literally write down like bulleted points of like ingredients, like grocery lists, like milk, eggs, bread, and then all of a sudden followed by something completely tangential about like the presentation that they have. So it's highly, highly unstructured, and a lot of what our team tries to do is to infer meaning in content, right? We try to infer who are you as a user, what are the kinds of things you like, what kinds of notes do you take, and how do we help grow that experience as you evolve as a person. But it's a really hard challenge when all of your data is so unstructured, and it's hard to find meaning in that. We support multiple languages, especially Chinese, Japanese, and Korean, which again is a different challenge, because we try to develop solutions that work across languages in a very agnostic manner, so that we don't have to create language models for every single language because we support every language. And of course, dealing with different search implementations across our languages.
With bilingual clients?
A
client is using 2 languages
yeah.
to support.
Yeah, we definitely. So we actually have users who use up to 4 and 5 different languages in the same account. Not only that, they have nodes with mixed languages in them. So you can have one node which is kind of, think of someone who's trying to learn Spanish, right? You have like the Spanish word and then the English translation of it. Now, like, it's pretty tough to try and figure out meanings of these things. So this is kind of a high-level, overview of the kinds of problems that we're dealing with, the kinds of solutions that we provide in Evernote. And now I wanted to kind of deep dive into one particular solution. I can't possibly go into all, and maybe they would make for interesting, different talks at the meetup. But I really wanted to dive into natural language search. That's something that I've worked on pretty closely, dear to my heart, and that's something that I would love to talk about. So, what is natural language search? So, in Evernote, we wanted to challenge the concept that search is always about keywords, right? Google has trained us to think only in terms of keywords. It's trained us to think that every time you want to find something, you have to remember exactly the word that you called it in that note. And we wanted to go beyond that, saying that's not the way our brains work. We as humans think contextually. If I want to find a particular node, I think about, I created this last month. I was in San Francisco, and well, I was drinking a bottle of wine. That's how I remember things. I don't remember it in terms of what was that exact word that I wrote in there. And so we believe that these two kind of approaches are complementary and should work together. The keywords are great at certain things, but contextual signals are also great. And so the attempt of natural language search was to allow users the ability to type free-form text and understand their meaning or do query understanding. And also do autocompletes on things like San Francisco. Of course, the main goal was we never want to retrieve results if you didn't have any matches. So it was highly personal to you. You would never see a completion of San Francisco if you never went to San Francisco. So these are highly personalized suggestions and highly personalized query completion scores. Another example, of course, everything I talk about has to be about food. And so, if I wanted to do something like recipes last month, Evernote should understand that this particular note that I have in my account is actually a recipe. It is a recipe, and I created it last month. And we have separate classifiers to figure out, what notes in a user's account are actually recipes. And then, we combine results together. So, when I search for something like this, I find my oven crispy fries recipe. So that's great. So this was our goal. We wanted to build a system and give the users this ability to do this. Of course, when you're trying to build any query understanding system, you have to know what are the kinds of things that you want to support, right? You can't support an infinite or unbounded list of things. And so, we looked at our grammar and we identified the key things that we thought were very critical for us to recognize. There were dates, for example, yesterday, last year, today. There were places that you've been to, apps, there were devices, which device you take it on, images, audio, documents, for example, PDFs, Excel, spreadsheets, things like that. And then it was more free-form content, like tags and notebooks, which were highly personal to you and differed across from users to users. So these are some examples. Recipes I clicked last month, Office documents I updated last week. And combining these metadata queries with content suggestions, that's where things got really tricky, is how do you combine things like Lucene presentation, where presentation is actually my intent to look for one of the keynote files I have and combine it with keyword of Lucene. How does the system understand something like this? And this is an example of a query and how it translated into our advanced search syntax. So if you search for my presentations from San Francisco, it would identify San Francisco as a place that you've been to, you took presentations there, and it contained the word search. And that was exactly what I was looking for, but there could be different interpretations of the query. So this was our query understanding pipeline that we have created, and I'll talk about some of the steps in a little bit more detail. So we started off with the pre-processing step, which is basically, it tends to be the first step in most systems, which is just sanitizing input. We followed by an instant detection system, content matching, ranking and verification, and advanced query generation. Go into more details. So mostly the pre-processing step to just take in the user's input query, sanitize it, remove stop words, do type head completion, which was a pretty complicated module because our type head suggestions had to work based on personalized selections. So if you type in San Fran, we would have to make sure we completed it to San Francisco if it was a place that you had been to. And so we
Is not a stop word here, or?
So we did remove some.
I mean, if somebody's done a subordinate clause in their query, you're going to drop the subordinate clause, or the fact that it's part of the description?
We dropped certain stop words. So we do try to, we initially took a naive approach where we first dropped all the stop words, and then we realized that there were some stop words that basically gave a lot of contextual information. And so we did a model where we tried to predict which stop words we should keep and which we should remove. And so we did like a partial stop word match after reserve certain types and leave the others out.
So you handle negation?
No.
Do you handle subordinate clauses?
No. Just very naive stuff. Just straight off. And in horse, we do subordinate stuff within the advanced grammar. So for example, like presentations would be Keynote or like Excel or XYZ, but not really complicated queries where the user says, in notebooks X or notebook Y and doesn't contain tag C, we don't handle those.
I want to search for something, but not about it, about competitors.
Yeah, no. And then we also did spelling correction and sanitization based on your input. So I'd rather spend more time talking about the entity detection phase because that was really the heart of our system. The others kind of follow suit. So I probably didn't mention this up front, but this was something we implemented natively on our Mac client. So it works completely natively. It had the challenges of kind of being on a client where you have to be careful of disk space, query time, things like that, not high processing power, as a lot of people don't have that. But those are kind of limitations of the solutions we had come up with. So the entity detection phase, we took in as input a pre-processed input query that was sanitized and everything. We dropped it into this module. First thing we did was very naive language detection. There's only so much that you can do in language detection when it's a query that might comprise of 2 or 3 words, and so we just passed it through a really simple kind of language part that could interpret what language we're looking at. And based on that, we had a semantic parser that was fed a grammar that was again language dependent. So this was the first time that we actually broke our kind of our principle where we always tended to favor language agnostic models. This was the first time that we said that we probably can't do that when we're trying to understand language queries. And so we built grammars for some of our supported languages in the first phase. And the language detector would feed into the semantic parser, choose the appropriate grammar. We used an anagram here, and so we wrote grammar files for a few different languages, cross-compiled it into the native Atomic platform, and then fed that in, that would generate the semantic parser that we used. And so,
whose parser are you working with? CCG, there's just a, Stanford has a couple, Berkeley has one, you have...
We just use the standard open source Antler.
Open source.
Yeah. And we use that. We had a few issues with it that we had to fix natively, and kind of, that's always happens when we use open source stuff.
What are the names of it?
Antler, ANTLR.
How many languages do you?
Currently only 2, English and Spanish. We wanted to do CJK, but we haven't got there yet.
Do you have a big lexicon of place names and types and things like that that feed the grammar, or is it sort of more?
So our grammar actually was only to support our metadata query expansions. So it would work only, it was not meant to support things like place names, just because the place names were something that was very personalized to each individual user. So we built those matchers separately in a separate phase that I'll talk about. But the grammar was basically just to support things like very structured, common metadata matches. For example, like dates, yesterday, today, and synonyms of those things. So you do yesterday, today, like date ranges, you would do things like
Documents.
Yeah, all those things with their synonyms and with their kind of different versions. So it was just to support those, the first phase of metadata matches.
Quick question. Was there a reason that you didn't use Stanford NLP or Open NLP?
We didn't find the need to, because it wasn't something that warranted that, and B is we did evaluate it and the performance was just something that we couldn't live with on our Mac client. So this was all done natively on it, and it did take quite a lot of time to process really simple queries.
Yes, what's the median size of an individual collection? Not the average size, because you said you had terabytes occasionally, but what's your median size?
We haven't really done that analysis because for us as engineers, it's really hard to get at that information. All that information is very, very strictly.
Well, I take an approximation, because if you're dealing with hundreds or thousands or even tens of thousands of documents, a straight linear search may find everything based on keywords without an issue. But if you have to do large documents or anything that characterizes, and you want to find paragraphs within that, then you may need something more complicated. And so it depends on what your data set look like.
Right, but I don't think our approach was we couldn't make assumptions about the data sets that we were supporting. So
what are you getting with your clients? What are they giving you? Are they giving you tens of thousands of documents of thousands of lines each, or is it a much smaller kind of thing?
It really, really, really varies. So there's no approximation that we could do because the hypothesis is that we have to be able to support 1 node, 10 nodes, 100 nodes, tens of thousands of nodes, and there are account sizes which is very common in Evernote, which is kind of the average, where there are very few nodes, but they are very dense, they're very long in terms of document size, and they're very scattered in terms of the types of collections that they have. So it's very hard to kind of say that we would favor an approach that would be biased to one particular type of distribution.
In long notes, do you find the relevant portions of, this could be a novel. Do you actually find relevant paragraphs or things?
So this is, we actually do that separately, but this system was just, you can think of this as just a query interpreter. Like it would just take your language query and translate it to an advanced search query. That's it. And then the advanced search query would then identify the documents that would match and highlight in relevance rank the associated portions. But those would then just do keyword matches. So for example, if I searched for notes that I took last month in San Francisco, all this system would do is it would take that language query and translate it into something that the system already understands with advanced syntax, and that would then just feed into something that the system already supports with regular keywords and language matches.
I don't see anything about synonyms going on here, like the Bay Area is a synonym for San Francisco.
We do that within, we do synonyms within our metadata grammar. So our grammar files itself are constructed using synonyms of all the types of things we support. And then in a separate phase inside our personalized entity detector, we do synonyms for the types of personalized spaces that you've taken, matching them with up to like 2 to 3 different versions of that base that we detect. And we even do things like localize to certain distances. So for example, if a place, we had a user who complained that their node was at the border of LA and San Diego, and it was mischaracterized, and so they wanted to kind of have that subtle difference.
San Juan Capistrano, halfway in between.
So we had to deal with things like that, but we didn't over-engineer it. We took kind of naive approaches by finding like closer geo boundaries and then merging them together. Just be able to support those kinds of things.
That's a good question.
Sure.
I use Evernote almost every day, and I haven't. Are all these features out already? I haven't used most.
This is out of the Mac client.
In the Mac
Only.
client.
Mac only.
I use it on my Mac laptop also.
Use your browser or
Maybe I'm a simple user.
Let's talk after this, and I can
Cool.
show you.
Okay.
That's kind of the biggest problem we had with this feature. Is that's kind of the disclaimer is, we built this thinking that we were solving a really important user problem, right? We were solving a really important user problem where users don't think in terms of keywords; they think contextually. They think in terms of places and who they were with and dates and when they were there. But what we realized after launching the feature is that we did have a certain problem with user education. We tried really hard up front to educate users that there is something like this. You don't have to think about keywords anymore. This is like a magic new system. But there's always, when you're trying to introduce change, there's always that problem that suffers from, it's a new thing, I don't know how to use it, I don't know what it is. So users did kind of find that this was something new that they had to learn when we were trying to do actually the opposite.
I search for a note that I'm looking for. When I find it, I know I'm going to want it again. I add a space and remove it so it pops to the top of the screen.
Yes. Love to do that.
So you don't have stars or things to say this is really important.
But that probably is going to change soon, where we're trying to get to this model of adaptive relevance. So based on the nodes that you tend to view often, nodes that you keep coming back to, we would just be able to surface that to you at the top of your list. So that is something that we're working towards, not out yet. Those are fun. Okay, so where were we? We're talking about the metadata. I should have probably annotated this diagram better, but so everything on that side, which is the parse and the grammars to support metadata searches. So for example, in the query that we had initially, which was my presentations in San Francisco, this the left-hand side would basically detect that the word presentation had to be translated to resourceful with presentation. And the part on the right side is basically a personalized entity detector. So that's all the stuff that we were talking about, which how do you recognize a place San Francisco? And it would only recognize the entities that you yourself are connected with, that your index recognizes or tells us about. So for example, if I've never been to San Francisco, I would never be able to kind of execute a query that says place San Francisco. Two ways about it. Some people say it's good, some people say it's bad, but we never wanted to return results, never wanted to return kind of zero search results ever. And we never wanted to give a suggestion that tended to do that. So when we built this personalized entity detector, it looked at your Lucene index, and it looked at certain core entity fields that we had in the index. For example, it looked at all the places that you've been at, and we had to store separate reverse geocoded names, and then look at localization issues and things like that. But we did a step of re-indexing on our clients where we went through the index and mapped out entities that we needed and restored them to the index. So now everyone's index would contain things like place names that they've been in. They would contain 4 important notebooks, tags, things like that we actually recognize as something that is personal to you. Our personalized entity detector basically created really efficient maps from the Lucene index into memory so that we could be pretty efficient in terms of being able to parse these and recognize all the required entities. We capped it at how many we would store in RAM because we tended to have issues of memory on my line. And that would feed into kind of a query intersector, which would take all these things together and make sure that both independently return valid results, and if not, it would drop one and the other into alternate forms of them to detect the right query intersection of the possible forms, because each of them could yield multiple results. So talking about kind of that personalized entity detector a little bit more, I think I covered this, but the main, sure.
So does this metadata search work from the Google search plugin you have?
No. It's just in my time. Because the core, that's kind of one of the biggest challenges we have is that when we tend to build these things, we build it natively. Our Chrome extension is pure JavaScript, and it requires a complete re-engineering of this solution that we just haven't done yet. And so right now it's only on Mac. This is somewhat a simplified version of the parse tree from our parser. It's currently showing an example on images taken last week. It's just a simple, parse tree created from what I'm looking at. And then there is a phase of, so after we do kind of this big entity detection phase, of course that entire entity detection phase, we make sure that we can return a response time of less than, I think it was 250 milliseconds, because we had to keep our total response time down to over a second. And content matching phase actually took way longer than that. And so we had explicit time collectors for each of the phases, especially, and that was especially difficult when we were dealing with Lucene, because we were actually working with Lucene 0.9, which didn't have a lot of capabilities that 4 had. And so we had to go in and build all these kind of breaks within enough code to get out of loops that were taking really long.
You're not really focusing on image recovery or image search here.
No.
So, like, say, putting yearbook pictures from some ancient year and said these are from a year, you couldn't go track that down in the metadata.
No, not the metadata within the image itself, but if you created that yearbook like 2 years ago, then it's basically the metadata against the note. So like the note create time, note create time.
It's when it was inserted in the data, it's not a date associated with the information. Or John Steinbeck wrote Vice and Men in the 1930s kind of thing,
Yeah.
and put that in there.
That's like way more. It would be a dream to get there.
Well, you said it was AI, so I'm putting it.
Yep.
You got Bob warmed up now.
Yeah, it's a dream. That's a dream. We're trying hard enough to actually recognize just semantics of certain words and grouping together phrases and like actually making sense of notes is really hard and design collection. Okay, so another big part of this entire system is the content matching phase. So after we do this metadata search, we do want to support all these entities, but we also want to be able to support text fields and prefix matches as well. For example, if I do things like my search presentation that I created in San Francisco, presentation and San Francisco can be detected pretty easily, but the word search, what do you do with that, right? Is it a keyword? Is it a tag? Is it a notebook? Is it just in one of the other kind of subtle fields? What do I do with that? Do I just drop it? And that's kind of the phase of content matching, which is to figure out what is really the intent of that query. How often, based on stats, how often, which of the fields does it match, and what is the likelihood of that being what the user wants in terms of collection sizes that are returned, and frequency of matches within each of these.
Do you build up those stats per user, or is
Yes.
Okay.
So everything is done per user. We have an architectural limitation of not being able to cross different users. Since each user index is completely isolated in the boundary of a single user, we can never talk across users.
Yeah, I thought those might be like parameters and you were talking before about how hard it was to create a relevance formula that applied to everyone, right? So I thought there may be parameters in that space rather than per user.
No, it's and especially, so we definitely don't do anything across users. More so because of privacy boundaries, but also we just never, the way our architecture is that two indexes can never ever look with each other. Specifically, on the service, we can do things where statistics can be derived from supplemental collections, where we build these statistics up and put them side by side with the index. But when we're looking at native implementations in kind of one of our desktop clients, that's just not a luxury we have, because we already have this usage constraints that we're really careful even when adding a single field to an index, just because of people complaining about how their drives are overloaded, that we just couldn't do anything else.
This question might have been already asked, but does users know how to use all those features? And I mean, is there any, I understand it's just for the Mac, but is there any tutorial or some hint that says do all those mass searches, or is there a product beforehand that you use, you say, oh, if this is like Gmail search, so we'll embed it, and how popular is it?
Evernote has like the classic problem of people not knowing how to use features beyond like a small subset. Like there's so many cool features.
It works. I can find the notes I created in but I never noticed it before.
Right, and so to answer your question, we did a lot of investment in user testing and figuring out how people would discover this feature. This was one of the things, this was one of the areas that we actually did spend a lot of upfront time trying to answer that question: how would users figure this out? And we did have, first launch experiences. The minute you hit the search box, we put kind of discovery suggestions of, the first suggestion the minute you hit the search box would be, you can search for notes from yesterday. Every time you hit the search bar, we would show you right at the bottom, like you can search by dates, by places, things like that. We thought we had nailed it. We thought we were like, that is the best thing ever. Like people are never going to like ignore this. When we did follow-up user testing, we realized that people just are blinded by everything that's in the search menu. They just hit the search bar and start typing. They don't even pay attention to anything beyond the first two things. And so we said, okay, that's not working. Let's move it up to the top of the list. Moved it up to the top of the list. Our user tests show that still no avail. They're so accustomed to doing things a certain way that they wouldn't look beyond, really what they want to get done. And so we put kind of a lot of learn more links all over, kind of point people to it. We're still trying to see if there's anything we can do, but so far, we have tried handling it.
Because you invested so much in it.
Right. We feel that this has a real core promise on mobile, specifically when you are, if we do it right, when you use kind of dictation and things like that, you can very easily, people don't want to type on mobile, right? You can very easily speak into it and say last week or things like that. Or maybe we use this in some combination with passive search or something. But it goes back to people saying, do people really want to talk into a phone? Like we don't know. So we're going to have to do enough explorations to figure out if this is a valid use case for mobile.
Quick question. Have you tried boosting based on entities rather than doing a filtering, so that like boost places which has got entity column, say place column San Francisco, rather than completely filtering out all documents which is not tagged with San Francisco as a place?
Sorry,
so you have entities like places determined, right? Ultimately you're doing a filtering based on the query, like place column San Francisco. Rather than doing a filtering, have you tried open up as a boosting documents which has got entity as place and value as San Francisco?
He's saying take San Francisco out of your Boolean query, then make it a ranking factor.
So I'll go with that. The problem is that it's purely hidden in metadata. It doesn't even figure into kind of the text index. These fields are not searchable in any other way than doing those kind of metadata queries. So even factoring it into kind of the ranking wouldn't really help, unless I'm misunderstanding the question.
I'll pull up offline.
Okay. Okay. I'm gonna go on. So the content matching content matching process was actually far more complicated than we thought because of all the constraints by the client in terms of performance, and being able to iterate over all the skills and Lucene 09 as well. What we realized was, we went straight to the guts. We went straight into the terms enough field, and we started, hacking away and kind of looking. When we wanted to actually do content matching, we went directly into looking at the underlying implementation of Lucene to be able to do efficient retrievals, as opposed to looking at any of the higher level APIs. And that actually helped us tremendously because we could do it way more. So this is, the rest of the boxes I think are pretty trivial. So after pre-processing, entity detection, content matching, we did a merging of we merge the different queries together to figure out the right combination of all these different intents, and we did a cross verification and ranking to figure out which of the multiple options, if any, we were to take, and then did an advanced query generation. Of course, we also had to convert this query into a form that the user understood because of user experience. So we had to do a reverse conversion where, if it said place San Francisco, resource presentation and text search, we converted back to a suggestion that said, did you mean nodes that were taken in San Francisco that contained presentation files and contained the keyword search? So something that the user could actually read as a sentence as opposed to an weird advanced token. So going back, this is what kind of would look where if you search the recipe /1, you said, are you searching for nodes with recipes and created since last month? Because users don't really care about anything advanced, they want something that reads out to them.
Did they look at that? Are you searching for, or did they just go right down to
They actually didn't look at anything in the search menu.
Only the really good users.
So,
did you look at it?
No people like me.
so a lot of our users, tend to just skip everything and, just go for it. We did make an improvement recently where if you actually search for something like this, it wouldn't populate the result in your search menu. It would go straight to the notice and show you the results. A few of the results on top, and we're still testing that out. We think that's going to perform better. When you actually go into recipes last month, it'll do the right thing, and it'll show you right there what it's doing.
The nice thing is you guys you're doing instant search, right? So I just click on the box and start typing, and a lot of times I'll look at the notes that are coming out and I'm seeing, am I getting the right thing or am I way off?
Yeah.
So the page is a little bit busy because the notes are changing
Right.
as you type,
Yeah.
which is nice.
We don't know if that's nice at all.
Well, I like that.
Yeah. So there are a lot of things that we're kind of, it is because it existed, as opposed to us kind of going back and saying, is that really what users want? And kind of challenging some of the assumptions that we've made like years ago, figuring out what optimal solutions are right now.
Can users specify any preferences on this? How much display or whatever?
So do you think the instant search is one of the reasons why people don't look at the autonomy?
It is one of the reasons. And it's not good or bad. So we're not trying to get people to look at the autocomplete. We're just trying, our main goal is we just want people to find their stuff in the way that's most intuitive to them. Whether it is, stuff that's flying around on this side, if that's working for them, then that's great. We just want them to be able to find their stuff as easily as possible.
What are your success metrics for?
We use a lot of click-throughs, especially for suggestions, in terms of when the user had an opportunity to click on something and when they didn't see it, did they click on it? And we use mainly those metrics.
I assume there's some, following on this question, there's some length of time it takes before they finally decide it's worth clicking on. If it takes them, they got to type, and it takes them a minute later before they finally have enough in that they're.
Yeah, we use that entire session of the suggestion, so we don't do it. As you type, things update in that box, but that entire time that entire search session is considered as one kind of chunk that we measure metrics for. So we don't tend to what was here.
Do you know how long your typical search takes?
Typically, it takes 30 seconds.
13 seconds.
30.
From the time they hit the first key until they click on something saying I'm happy.
Well, I'm just wondering how much you try to differ from Google and the opposite, like how much you try to see things they embedded as Google search and either implement or with the tools you're using like the technical tools that you see and stuff you mentioned, but generally, like how much you try to take on them or do like.
In terms of functionality?
In terms of everything in search, I mean, you do local search so on the data, but still they have quite few techniques they use. So how much?
I think.
I mean, just as a product management side.
I think that the way we look at it is we look, Google is definitely the pioneers of search. Like Google is definitely kind of Google and search are synonyms. But the way we look at it, Google is fundamentally trying to search the entire world for information, right? You're trying to search for anything and everything in this world. And the other thing is with Google, when you get search results, you don't know what you're missing, right? You know what you get, you don't know what you didn't get. In Evernote, it's a very, very different problem because in Evernote, it's actually your world of information. You know exactly what you expect. You know exactly what you want. And if you don't see something there, you know it. So our problems are a little bit, different in that respect.
Do they embed their own techniques into, like, let's say, Gmail search, or now they're embedding more social information into search? I mean, they go in and you have local searching with phone as well with the Google bar. So they embed some of that stuff. I'm just curious about. I'm sure you're very innovative in that stuff. But, like,
though we think that our directions are very fundamentally different, we of course do look at Google in terms of what they're doing as aspirational for us. So for example, Google Now, super cool concept. Being able to always anticipate what you want when you want to get drive time information, weather information. We wouldn't ever care about that in Evernote, but the concept in terms of anticipatory and predictive search, great, amazing. The way they executed it, somehow great, a little bit. We do look at a lot of different search technologies to kind of draw on certain things that we can use, but we're very careful to kind of figure out, does it really work for everyone?
Yeah.
Does it work in our ecosystem?
Thank you.
And how does it differ from, say, the Google desktop search?
I'm glad you're asking a question.
Right. So Google desktop search, which browsers, I haven't used that, but it's very similar.
Excuse me, could you speak louder? What was the question? I didn't hear from here.
Yeah, how does this compare with Google desktop search, which also goes to all the presentations, notes, and everything else, I guess?
I mean, anything that basically is a collection of personal data is kind of similar in terms of what they're searching, but I think the front end of the functionality that's provided is different. So for example, we could ask the question, how is this different from Gmail search? How is this different from any kind of search box in a personal collection? Well, primarily the use cases are kind of the same where you want users to find that information quicker, but the way in which we're trying to help users discover this information, I think is different. I haven't used Google Desktop Search in years now, so I don't know what exactly they have innovated, what they have not innovated in that space.
Has anyone used it? I haven't used it recently, though.
They stopped support for it. They stopped for 2 years.
Oh, that's good. No issues.
So
Okay, I
quick
think that was all that I had to talk about, and I'm glad.
question.
We are hiring.
What is the click-through rate CTR of the natural language based?
It's pretty low. I don't have the numbers off the top of my head right now, but it's so if we compare our type-ahead search click-through rate numbers are super high. They're at I think 55 or 60%, which is amazing given that people don't even look at that search menu. In comparison, I believe that NLS is closer to 15%. It's low. Or I think even lower than 15, probably 10%.
So how are you powering the recommendations? We're using a collaborative filtering. Sorry, we're using, say, topic modeling for recommending news to users based on the context?
Recommending.
So there was recommendation of news articles, right?
Oh, that's a completely separate topic. That is, we should actually come back and talk about it. That's a feature we just launched in November, and we actually did another launch of it like a week ago for Nikkei, where we show Nikkei news as well for Japanese users. So we actually were able to do a Japanese relevance detection to match Nikkei news as well. It's a completely separate engine that surfaces relevant content from news and matching over there. I think it's way beyond the scope of this discussion right now, but we can chat about it.
Why didn't they use Elasticsearch or Solar rather than Code Lucene?
We love having control. We absolutely love going into the inners of Lucene, and we do it all the time. We love that kind of control that we get.
So this could be a little off topic, but as far as I understand it, Evernote does not encrypt data on the server. You can encrypt notes inside notes, but you don't encrypt data.
Yeah.
Is that something you envision changing? And if so, how would that affect strategies like around search?
I think that is something we have considered. I don't think it's something we're going to do in the near future. It's definitely something that certain users want. We have talked about options of kind of maybe at some point letting users select certain notebooks that they want completely encrypted, and everything in that is just not visible at all. And obviously, search in those cases would not work because if everything's encrypted on the back end, there's no way for us to be able to search for that. So it is something that users would lose out on if they went that route.
How big is your search team?
We don't have a separate search team. It's kind of the augmented intelligence team. We are currently 4 engineers. We have a search researcher who we got from Germany. We have an ML expert from Australia, another ML engineer who just joined us, and then a core software engineer. 1 designer and 1 QA. So we're a team of 7 right now, 4 core engineers, looking to grow pretty rapidly this year.
Pretty ambitious what you're doing for only
Yeah.
half a dozen people.
I'm very impressed. That's impressive.
We have
Most of
half a
the
dozen
features.
search people from eBay right here. I sit with the expert.
We tend to orient projects, on our team as very independent projects. So we have kind of 1 engineer driving the entire project from inception to completion. So at a given time, we do have the bandwidth to do 4 projects.
A question about spelling. I was looking at the Mac client for all these 50 features I had overlooked before. But for spelling, my motor skill is kind of flat. So I have a Yamaha. I type Yomaha. It doesn't spell correct. It's only edit distance 1 away. So I was just wondering.
It should find it. We should look at it.
Yeah.
Should definitely.
So that was one question, and then the other is there's a company I've always thought was pretty interesting. It's Chenli down at UC Irvine, and they do this. And they do instant search with corpus-based spell correction. So it always spell corrects to words that are in the document set. But since these are small document sets, that might actually work nicely.
We do that. We do exactly that.
Okay.
So we definitely adapt our corrections to your corpus. And so if you spell, like if I spell colorful with C-O-L-O-U-R, like it will correct it to the way I can spell it.
I was making a different point actually. What they do is, as you're typing, they show results, and then when the result set starts to get small, they'll guess, oh, maybe you have a typo, and then they'll correct and it will get bigger. And then if you keep misspelling, it will get smaller, and then it'll get bigger again. It's kind of interesting.
Yeah,
they have a demo on the web. People can look at
the approach we take is we do the same thing where as you start typing, if it gets smaller, all of a sudden we realize that you've got a typo, but we don't expand the suggestions. We just show you that one spelling correction suggestion. We don't kind of snap back up to a list of.
Yeah, like they'll start out with
interesting.
they'll show you, spell corrections maybe that are edit distance 1, and then if your document set's getting small, then they'll start being more and more aggressive. So
That's very interesting.
it's interesting. If people are interested, they can search for. You can look for search S. It's search to Chen Li Irvine.
Christian, how do you do relevancy A/B testing for the relevancy models?
How do you do A/B testing for relevancy models? We don't really A/B test it. We do a lot of, we kind of follow more of a serial model. So our QA engineer on our team is tasked with exactly one thing. Like, it's to make sure that the quality of our algorithms are on track in terms of metrics that we define up front. Specifically with relevancy search, we build very, very large data sets of manually annotated relevance metrics. We use multiple assessors to make sure that we're actually measuring the right thing to kind of account for assessor biases as well, because relevance is such a kind of personal, subjective thing. And we make sure that when we actually ship something, we're shipping a version that hits the numbers that we do want for success, for pre-success. But we tend not to actually A/B test in production two different models simultaneously or kind of across users. We do all that internal testing upfront before we even in serial models.
Can you talk about the measurement models we use, like NDCG or MAP or ERR or measurement strategies with an expected result set?
Sure. Do we have time to cover it, or? Okay. So we use a number. We don't use kind of those numbers at all. So we define very, very different numbers. We use more very naive. We call them P at 1. They're kind of metrics that we define in-house. P at 1, P at 2, P at 3, P at 4, which is basically position. But we account for positional deviations in terms of ranking orders that get returned, as well as popularity of collections that get returned. So we have a number of different collections that we use internally, which is, we have corpus collections, all like the major corpus collections, like, what is it? The Google massive collection. I don't remember the exact name. We use all those collections across different languages, and then we measure just basic precision at 1, 2, and 3, and then measures and recalls. So it's kind of just very naive basic ones. And then the bigger kind of problem we face with doing the assessments is how to determine a threshold for success, because our metrics are usually all over the place, especially with different languages. So with Japanese and Chinese, Japanese, and Korean, we see very, very different results in terms of our deviations for the relevance metrics. And we have really hard times in figuring out kind of what is our threshold for success when we actually want to launch something. That's kind of a bigger problem.
Thank you. Could you any other question?
You mentioned about the semantic analysis, right? With a team size of 4, how are you managing that? It's a large loop. It's not one-time process. It's a huge database, right? Can you talk about it? How are you managing it? How it's being handled?
Are you talking about the analysis in Evernote in general, or just with the natural language search?
With the search, with the semantic analysis feeding back into the search index.
So maybe I mentioned it wrong. We currently don't do any funky semantic analysis on notes. It's aspirational. We just do it in this type of search right now. We did do
pure losing infrastructure. You don't add anything to it.
No, not right now. The only semantic kind of grammar-based analysis that we've done is just using the grammars. We did do a lot of intern projects where we looked at different open source tools in terms of topic modeling and kind of those solutions. But The problem is they didn't even scale for what we were looking at in terms of performance numbers. So we have very strict architectural constraints on our servers. We can't use more than X amount of meg in RAM at a given time, just because the servers tend not to like it. And so, especially with when we're using things like NLTK or kind of these really great libraries, they don't play well with our servers. And so, all of our current efforts that we've used haven't really gone down well in that way. But it's purely aspirational at that time. We do want to get to a point where we can understand content that's there in your Evernote account from highly unstructured data. We did build recipe classifiers, but that was just a pure classification problem that we could build pretty easily for one that classifier like recipe. So we haven't done anything major yet.
Are you using machine learning, using Spark, something? For analytics on the content, like generation of this values, like places or recipes?
For recipes, we did use because we built classifier, but not for any of. We don't really need it for any of this because we don't need any ML techniques when you're actually dealing with like recognizing places from a predefined list of place names in a corpus. Like there's no need to engineer that.
I'm assuming you're memory mapping the entire index per user, is that right?
We memory map it to a certain extent, but yeah, it's mostly memory map in efficient structures.
So I apologize, this might be more of the same question, but if you have one index per user, what does your infrastructure look like? I mean, it's able to handle multiple indices and processing the receiving instance, or are you running like multiple VMs or containers or something?
Yeah, so we run multiple VMs. So we have a sharded architecture. We have, right now, we have like 669 shards, each kind of one VM, 200,000 users approximately per VM. One single Tomcat instance for that VM. And it scales pretty well.
Yeah.
Like, no issues. The only major issues that we had, every time we try to do something fun with Lucene and search, our biggest bottleneck is this dial. It's our biggest bottleneck. And especially when we were on Lucene 2.9, that was something that really restricted our ability to innovate. The minute we moved to 4.0, we saved a lot in terms of this file, we saved a lot in terms of memory, and that just freed us up to actually do more. So that was a big move for us.
Did you have any challenges in re-indexing, say, 30 terabytes of content? Like how fast were you able to re-index everything?
It took us, our first re-index from 2.9 to 4.0 took us a duration of 2 to 3 months to get right, to go through like 100 million user indexes. But more so because we did it very carefully in terms of like staging multiple users, making sure that we've done it right. So there was a lot of hand-holding between our teams and ops to make sure that we actually got through it right. We did have certain cases. The way our systems were architected were that two versions of Lucene could live together, so we didn't have to migrate an entire shard at once. We could migrate, like say, 50 users at a time, even though the remaining 190,000 were kind of not migrated over. So that really gave us a lot of flexibility in architecting it this way, because we could do very, very small daily step migrations to make sure that we were not corrupting any data along the way. It did take us like a good 3 months to get through all the indexes, but now we've moved to a model. We've done it a number of times, and we've moved to a model where we try to do re-indexes for all of our users every quarter, so that we can actually continuously innovate. And we want to add new fields to the index, we want to kind of bump the Lucene version up. We do have that flexibility to do it now because we've done a number of trial runs and we can move fast enough now.
Do you store the content in MySQL? Have you thought of storing in Hadoop?
We don't need to because we have MySQL scales pretty well for us. We don't really need anything in right now. It's again, all the data sharded out. We have MySQL instances for shard. We don't have like a big MySQL store that stores, all the terabytes of data. This data is across across options.
So if the number of users increase to 1 billion, is this approach scalable?
It scales because we shard it out, right?
Okay.
So like if as our users keep growing, we just add more shards, and the next like 200,000 users go to that shard. The next X users go to that shard. If we tend to have a problem like right now, shard 1 is the one that's the most heavily loaded because it's the one that has the first set of Evernote users, right? The most active Evernote users were on it. So now it's unproportionately skewing in terms of load. The way we solve that is we add more and more hardware to kind of let that scale.
So you would have an uneven number of replicas for certain shards, right, based on the QPS. Is that how
Yeah.
you do that? And you dynamically spawn, if there is more load, do you dynamically spawn more rows?
So we freeze kind of, we just add kind of more SSDs and things like that to them, right? But we definitely are now in a place where we can better predict kind of how our load grows and make sure that we're leaving enough room for growth as those users age over time, so that we can better handle it.
So you use SSD, you don't use SAN, I'm assuming.
And so what are the key reasons for having 100 million plus indexes instead of keywords? Because there's a lot of redundancy as well, right?
No, one index per user actually works really well for a number of reasons. A is because we have a sharded model. So we do want to isolate users to a particular shard. There's no reason for us to have like this one big system. It helps us kind of isolate problems to shards, helps us move really quickly, it helps us kind of migrate to a number of different things very easily. Also, there's no reason when you're searching, you really should be searching your own index, right? One user should be searching their own index. We could partition it like when you have a big index, we could partition it. But it really, like, if a user's data is corrupt, we get an issue, it's really easy to just delete the index and recreate it. Right? It's as easy as that. Also, we have huge security or privacy kind of concerns. Evernote is one company that's paranoid about user data privacy. So they don't want any chance of two users' data crossing boundaries. One user's data should live in its own silo, it should not talk to another user's data because it's kind of your collection. It's not a social network, it's not anything. It's your data that you trusted us with, and it should live in kind of your kind of index that's siloed off. So there's kind of a number of reasons that make it work really, really well in our advantage. And we've never kind of doubted that decision or never ever thought to move away from it.
It's a concept of group users, only single users, always.
We have Evernote business users. So we have an Evernote business offering where the promise is that in Evernote business, the data is owned by the business. And so it's a business account, even though there are 10 people in the business, all of that data is kind of grouped together in one index. So then it's kind of your business index. You leave the company, the data stays with them.
How do you automate the sorry, go ahead.
Do you build your own data centers or you use this?
Our own data centers.
You don't use data centers?
We have our own data centers.
We have your own.
We don't use any like AWS or anything. Everything's in our own data centers. We have 2 data centers geographically apart. So if immediate it's we would still go, but we have one that's offshore as well. So it would take time. We transport it, but it will be unavailable for maybe a couple of weeks.
What is your biggest challenge right now? Is it like maybe the infrastructure or the user adoption or the user client that's on your Mac?
Our biggest challenge is that we need more people.
Yeah, that's right.
We need more people.
Except for, no, but what are you going to use those people for? Seriously, like what is your biggest challenge? Like I understand about adoption, but where do you see it going? Like You're saying we're going to make it smarter, or you're going to make just more clients as it is right now? Like, what's the vision for search for your product?
Or specifically for the AI team is our number one kind of thing that we want to get to is we want to understand our users. We don't right now. We want to know who you are, what do you like, how do you grow over time, how do your interests grow over time. Because once we know that, once we are able to kind of identify you, your collection, we're going to really be able to get you. We're going to be able to mold ourselves around who you are as a person and are able to kind of offer you the kinds of things that we do want to be given that. So that's kind of the high level what we are trying to solve for technology.
So how did you come up to the things that you showed so far? That's what you understand about the user? That's what you're researching, like user behavior and solutions for that?
So right now, all of our solutions are pretty much just based off of pure search capabilities and information retrieval. We see a document, we're viewing a document, we're able to figure out, do kind of pretty smart similarity computations across a number of different collections to figure out what it is that you want. We're not able to understand what is that note actually about. Are you a person who's interested in basketball or sports? Are you a person who's kind of a Michael Jordan fan? And how does it grow? Are you a person who's interested in technology right now? Are you an engineer right now? You grow into a product manager. Who are you? What does your data say about you? We don't know that. We don't do any of that analysis.
But I'm just wondering, once, let's say I'm searching for my recipe about, instead of chips, computer chips, but I have everything is recipes about French fries, right? And you found the article I want. So that's it, you're done. I mean, isn't it like that? Because that's what you're saying. That's the whole
that's search as we know it today. That's not going to be search in a year from now. Search in a year from now is not going to require people to actually do these kinds of searches. Search in a year from now is going to know who you are and what you want and just give it to you.
Aren't we talking about if I have 20 notes in my Evernote, that's all I'm searching for. So I have 20 notes. I mean, if I have 200, that's more. If I have 2,000, that's even better. But it's not the entire web.
Right, but that's when you're searching.
Okay.
Like, you shouldn't need to search. The idea of Evernote is if you have put 20 notes in your account, we should be able to kind of give you information not just from your account, not just when you're actively searching, but irrespective where you are, to kind of improve who you are as a person. For example, let's say you have 20 notes in your account and you're talking about artificial intelligence because that's kind of the field you're in. Like, irrespective, even if we know that, we can tell you that, hey, right now, there's buzz in the industry about how artificial intelligence is going to end the human race. Like, it's ridiculous, but yeah. And help you grow. If all of a sudden we see that you're doing research about product. If all of a sudden, we see that you're doing research about product management, we're like, hey, this person is an engineer, now he's trying to go into product management. How do we help him grow? How do we help him make him more productive? Like, what is it that we can show him? If search is going to die one
day. So you're going to switch to the www or whatever it's going to be at some point. That's what you're saying, right?
What
I mean, you're going to switch to search the entire web at one point.
I mean, it depends how you look at it. I mean, we don't want to search the entire web. We want to search for stuff that you are interested in, that makes you productive. Maybe as a back end, maybe at some point we do have to post multiple collections. Right now we post new sources from things that that we do care about. But it's kind of, we really want to be that external brain of yours. We want to be that thing that's constantly working. Your data is actually your brain. It's kind of that thing that's constantly working for you, making friends with different people and just kind of getting you, helping you grow.
About clients, because what you're doing is a little bit on the Mac. Can you? I don't even know if it's possible how it works, but can you integrate it in Spotlight so that Spotlight searches your Evernote notes? Because it doesn't do it now.
It doesn't do it now, but it can.
Right.
It's planned. Sorry, planned.
Do you also, whatever user queries, do you maintain history like user history stuff?
We don't maintain complete user history.
You pretty much know the user.
We do want to. We don't right now. Our only limitation is the number of people we have on our team right now. We do maintain your last 5 searches, kind of that, but we really need to get to a model where we know even your search patterns, right? We don't even know your search patterns right now. We're working really hard at getting there, but you know, if we know what you click on, what you search for.
Yeah. The good part is you already know the specific user. That's the good part.
So you can't have a search that refers to a previous search and use the pronoun in the middle of it.
Yeah.
Not right now.
So can you talk a bit on how you distribute your index across the various data centers in the globe? Like, do you use any queues, or is it just replicas of the shards going across the clusters in different data centers?
That's actually a very good infrastructure question. I wish I had someone from the infrastructure team here to help answer that, but it's just replicated across, you know, as far as I know, we have certain set of users dedicated to a shard. We replicated twice at least, and then we have failover systems. We, you know, all of the global data is hosted just in these data centers. We have separate service for China that's hosted in service in China itself.
Do you use any automated deployment for like field additions of schema? Do you use any automated tools like Puppet?
We do use Puppet.
Let's have a maybe last question. Then we wrap up tonight's session. Any one more question?
All right. In summary, why are you calling this artificial intelligence? I can see you calling it.
We're not calling it artificial intelligence.
Okay, you said AI. That's why.
Our AI definition is augmented intelligence.
All right.